All right, hello Advanced Lab. This is a syllabus video to discuss the syllabus of the course. As we will discuss momentarily, there's not a set time that we will all meet in class, so there's no opportunity for me to go over the syllabus and talk about how the class is run. So instead, this is the video you'll take instead. After you take the video, you'll see here, this is the front page of Canvas. I'll use Canvas with the modules kind of structure. There's a syllabus quiz along with an intro survey where you introduce yourself. But the syllabus quiz, the idea there is you'll watch this video, read the syllabus, and then answer that. So everything I talk about today, or in case I forget to mention it, it'll be in the document, will be answerable in the quiz. So let's start with the document here. Syllabus is the syllabus for the whole course. So the advanced lab, so this is physics 3530 or ENGP. So I think almost everybody here is likely a physics or an engineering physics major. So you guys know that this is a required course. I'm the instructor, Lewis McLean. My office is in Stern. Just to give you a background on myself, this is my third year at Tulane. It's my second year teaching this course. But before I came here, for about 5 years in my previous job at the RIT, the Rochester Institute of Technology, I taught their version of the physics advanced lab, which was actually 2 semesters. So I would teach it twice a year usually. And so I've been teaching this advanced lab for quite a long time now. So I kind of know what works best and what doesn't work. In general, I'll just admit this is one of my favorite classes to teach. I really like kind of introducing people to higher level experimental science and showing you how really this works. Some people think they start up not liking experimental work because they've only ever done labs that don't really work, and then they take this class and they find out, oh, actually they do like experimental work. My background is in biophysics, which is basically taking physics principles and applying it to biological systems. And I got my PhD at Georgia Tech in that field. We'll have 2 TAs for this class. It says here Amir and Brad. Those were the TAs last year. I'm not 100% sure who the TAs will be this year, so just keep an eye out for the emails. As I'll mention a couple of times, email is the best way to contact through this class, just because of the way that it works and that there's no like structured meeting times. In general, I respond to emails pretty well within a day. However, secondarily, I haven't created it yet, but for this class, I will be creating a Slack channel for you guys to ask questions, usually about the material of the labs themselves. That way, you can help each other. The TAs can answer the question. Whoever gets to it first, it's usually the best way to do it. Whereas if you email me, I might not respond, but if you post it there, one of the TAs or another student might see it right away. So I'll send an email out when that's up and running. Like I mentioned, I'm going to be sending lots of emails in this class because that's the only way to communicate with everybody. Class hours. So like I mentioned, there's no set time for the class. It's a little bit of a choose your own time. If we go out of here and we go to the home page, there's gonna be a lot of documents here that are that I can see that you guys can't quite see yet. But if you scroll down to the sign up sheets, you can see this. Well, you can see the analysis one, but the experimental sign up sheet. Basically, what you'll do for lab is you'll click on this. It'll take you to a Google Doc that everyone has access to. This will list the times on it. Again, these times are placeholders from last year. I'll update it as soon as we know the TA's availability. And then what you'll do is you'll sign up on the sheet for which labs you want to do. So you'll put your name next to an experiment on a certain day, put the time there, and then you have that time reserved. And so that's how the class scheduling works. We'll talk more about that as we go. There actually are not any labs for the first 2 weeks. So that makes our life a little bit easier. It's a little bit of a slow onboarding because of the fact that registration is still open. You do have assignments this first 2 weeks, though, and we'll talk about those in a second. There will be presentations in the last week and a half of class. These basically, we'll talk more about that later, but that's kind of the final activity for the course. So instead of a final exam, you have a final presentation. Like I mentioned, there's no exams at all in this course. So this is a course schedule. This is kind of detailed. So for the first 2 weeks, you'll be doing data analysis and coding assignments. So for the first 2 weeks, we're not going to have any lab. We don't have any class, but instead what I'm going to do is give you assignments that have accompanying videos like this one, where for some of these, I explain exactly how to do analysis that we're talking about in this class, some statistical analysis that you might not have seen before. Then I'll ask you to do a couple of assignments. The data analysis is just pen and paper, do some error propagation is mostly what those are, and some other topics as well, standard deviation, that kind of thing. The other one is coding assignments. So there are going to be some coding assignments as well to get you kind of up to speed. I think a lot of people have used MATLAB before. For this class, I'm actually supporting Python. You can use MATLAB if you like. It doesn't actually, I don't really care. What I will say is that I am much more experienced in Python, and I can help you a lot more. As I think the kind of things we do in this class, Python is a little bit better for. It's just quick coding and plotting and analysis. Also, in general, if you know MATLAB and you don't know Python yet, it's good for your resume to learn another language, to be honest. And so I would highly recommend everybody use Python. I'll give you some links. You just download Anacondas is a good one to start with. Or what do I use? Spider? Spider, yes. I have links in the assignments. Okay, so that's the first 2 weeks. You'll have a data analysis and coding assignment due after this week, and another one after the following week. After the first 2 weeks, we're going to do kind of a little intro lab, week 3 and 4. So you'll do your first lab. You'll go to one of those links. You'll sign up. You'll do a lab. What you'll notice is that this one you're not going to write a paper for. So this class is very paper intensive. That's because it is fulfills writing intensive requirement 2 for your degree. So there's a lot of writing, but last year we kind of jumped right in and started doing right away, and I think this is a little bit better. Let's start with an experiment. So we're going to start with an experiment. You're going to sign up. You're going to do the analysis. I'll talk more about like how the structure of that works. You have 2 weeks to do it, but really it's 2 weeks to do the experiment, and then you actually have to come have a meeting with me and show me your analysis. After that, we're going to start the schedule as it normally goes, in that each lab has 3 weeks for you to do it. So week 1 is basically do the experiment, week 2 is do the analysis and meet me, and week 3 is write the paper. And so labs 2, 3, and 4 each have 3 weeks. Then that takes us to the last 2 weeks of class. You'll have presentations in the last 2 weeks of class. And then the very last day of class, what you're going to have to do is a rewrite of the first paper. So part of the requirement for two-lane writing 2 is doing revision. So you'll rewrite it. And that makes sense too. You'll write one paper. I'll be a little bit nice about grading, but I'll give you a lot of critique. Then you'll try it again on another experiment. It'll be better. And then you'll go back and rewrite the first paper entirely. And then it should be like really nice. And you have feedback off 2 separate papers, and you should be able to kind of basically do really well on that. So that's the overall structure. If anything changes, I'll send an email. That'll be a refrain. Required materials. There's actually not a lot. You need a computer, either a laptop or a home PC is fine. We're going to be using digital lab notebooks, so you'll have to keep track of a digital lab notebook. And then I do have a textbook for the first 2 weeks of data analysis, but I put it literally on Canvas. It's a PDF that you can access. So the rest of this is course description. That's kind of for the legal reasons. Who cares? Course objectives, same thing. These aren't for you guys. These are for the admin. But basically, it's a lab course. You're going to do experiments, analyze these experiments, interpret your results, etc. Write a paper. So these are the brief topics that we'll be talking about. So data collection and error analysis. That's kind of the first 2 weeks. Then we'll do experiments. You're going to do 4 total experiments, and you get to pick. I have broken them up into like easier ones and harder ones. So you're going to do 2 in kind of the simpler section, and then the last 2 will be on the harder section. But the overall list, we have charge to mass of an electron, Faraday rotation. That's the idea. If you put a magnetic field on light, you can rotate its polarization. Gamma spectroscopy, thermal radiation, atomic spectra, fine structure, photoelectric effect, superconductors, and double slit interference. So those are all the experiments we have running right now. I think it's 7 or 8. And I think they're all really good. In the past, some of these experiments weren't working super well. We had ones that were broken. So I've slowly replaced some of them that were broken. I fixed others, and I got rid of some other ones. So all these experiments work really well. So you shouldn't be scared off of any of them. The grading, as most students are interested in, how does this work? So 10% will be homework. That'll be kind of the stuff you do in these first 2 weeks, plus maybe some assignments later on when we get to practice for writing papers, that kind of thing. Then 15% lab check-ins. I'll talk about that in a second. 45% for lab reports. So each lab report is worth 15%. So you write the paper number one, you write paper number two, then you rewrite paper number one. They're all worth the same amount. Your lab notebook is also worth 15%, if you notice a theme here. And the final presentation is also worth 15%. Okay. So grading scale. In general, grades, I don't have hard cutoffs. It's not a situation where, okay, if you have a 89.8, it's a B plus, and I don't do things like that. What I do is I look at the class as a whole and see where the gaps are. Typically, the grades are where you expect them to be, but I might end up adjusting slightly at the end. I don't curve individual students' grades, obviously. I can treat the class as a whole. We can talk about that more later, but if you talk to anybody else, I've never had a complaint about my grading style. Okay, let's talk about the individual components of the class. So in general, we're going to have a Slack channel. Make sure you ask questions there because they can be easily answered. Also, nice thing about Slack is you can put pictures in of plots, of code, you can upload code, and it's a much easier way to communicate how to fix your problem rather than trying to describe it over email or something. Let's talk about expectations of lab work. So this class is entirely asynchronous. That's a design choice by the department. This is really tests kind of your time management skills. That's honestly the hardest thing in this class is time management, more so than anything else. So I've really structured it every week to give assignments every week or 2 weeks to kind of keep you on task, but it's up to you. Like I say here, you're expected to spend at least 3 hours a week in a lab. So that's basically like this is a course, right? This is I think a 3 credit hour course. So you're expected to spend 3 hours a week in lab. That's not unreasonable. Just because you went into the lab one day to do an experiment, it doesn't necessarily mean you're done. It might not have finished and you have to go back again. That's okay. Analysis and writing and all that stuff is done outside of class. You do 4 different experiments and you have 3 weeks to complete each one, except for the first one since you don't write a paper on that one. Ideally, you want to work in groups of 2. That's the best way this works is partnership. It's actually much easier than doing it by yourself because often what will happen is that one person will be recording data while someone else is off tinkering, and it works really well with 2 people. Sometimes 3 can work. Some experiments it's actually really nice, but some experiments the third person doesn't really have a lot to do. I really would discourage working by yourself. It just doesn't work well. Last semester I had a couple people who tried to work by themselves and they didn't end up having as much success as everybody else. So in the middle of each lab, and the last thing is, even though you're working with a partner, everything you do is on your own. So everyone's gonna have their own submissions for lab notebooks, papers, everything else. So everything's solo, you just do the labs together. In the middle of each lab, so usually week 2, I'm gonna have you guys check in with me, so that way I actually get to meet you. So the way this is going to work is, actually if you go back to the modules here, under the sign-up, there's actually an analysis check-in sheet sign up. That's basically just my office hours. I have other classes and other students can reserve those times as well. But the idea is once per lab, you have to make an appointment with me. Everyone in the lab has to come, all your partners or partner. And then we talk about the lab. You're required to have some of the analysis completed at that point so that we can talk about it. If you just come up and show me raw data, that's not really helpful because I can't really tell you if your data is good or give you advice about how you're going to analyze it. So in general, this is the structure. The first week and a half, you get the experiment working, take data, and begin analysis. Week 2, that's when you do analysis and you meet me for the check-in. On the 3rd week, basically, if you need to take more data, do that, and then you need to write the report. So this is how this works. I think it's a very reasonable amount of work. You just have to stay on it yourself. So like I mentioned before, at the end of the class, you'll revisit the first lab you wrote a paper on. Many times I also often include additional analysis that I want you to do. So sometimes you have to take more data or do something differently. That's okay. And there you have to rewrite the paper. So at the very beginning of the class, again, we have homework. These are mostly Python coding exercises and analysis, traditional homework styles. Let's talk about those briefly. So there are actually two of them available right now. If you go to assignments, so those two things, it's data analysis 1 and then certainties. These are the other ones that are invisible for you right now. So if you go to data analysis 1, this is the first one that asks you to code. So I would recommend downloading Spider, which is a standalone IDE coding to download from your computer. You can use any Python distribution that you like. Then I introduce a Python shell. So I'm going to give you a shell to start with. So I'm not getting you to start from zero. I'm actually giving you support, help you make your plots look pretty and that kind of thing. And then this is the actual assignment. It has the wrong date. This one says spring 25. I'll update that. But this is the assignment itself. There's some data. So you take this data, which is fake data. You plot it. I'm showing you how to do this. And then you do some analysis. So this is the instructions for what I want you to do. Basically, I give you fake data for, it's like mass on a spring, and then you run through all the traditional analysis you would do. You can see there's a lot of text in these assignments because I have to tell you what to do. Okay, so for the analysis assignments, those are also an opportunity to get your OneNote working. So everyone's going to be using OneNote for lab experiments. I think that's probably the next thing here. Lab notebook, yeah, it's down there a little bit further. But everybody's going to be using OneNote for your lab notebook. It's a digital lab notebook. It's not the best thing in the world, but it syncs really well, and it's a really good teaching tool. So I have here an example of a lab notebook. This is what you're going to start with. You can see over here on the left, I have the two different experiments. Here's atomic spectra. Here's photoelectric effect. I haven't started that one yet. So here's atomic spectra. So these are the sections you would like in your lab notebook. You have an introduction. You put an introduction here. What are you doing and why? This takes place of like writing it down on a piece of paper. So I say some of the information here is the same as manual, some is not. Don't just copy paste, write it in your own words. This is basically what are you doing. Then you have theory section. The theory section will have theory from the experiment. Some experiments have more theory than others. You can write out equations, insert images of them. I would recommend getting used to using LaTeX to write these. This is a website called CodeCogs here that actually lets you use LaTeX. Okay, the integral from a to b of x squared, right? And then it should make the little guy down here to make it look pretty for you. And it uses LaTeX coding. So that's a really nice way to insert that. That's not required, but you'll get used to it. There used to be a good way to use Microsoft Equation Editor in OneNote, but like everything, Microsoft just slowly makes all of their products worse and charge more for them. And they put AI into everything instead of making it work the way it used to work. Okay, so you put this stuff here. Then the most important things are the experimental logs. This is what you're doing. On day 1, you did this. Day 2, you did this. Put pictures of your equipment in here. You should have a bunch of pictures of your equipment, labeling what things are, what wires are, etc. I say pictures are useful. Annotated pictures are better, and drawn diagrams and schematics are even better. Don't just throw a picture in there without any comments. That's bad. Experimental log day 2. So this is like if you came in one day, did half the experiment, come in the other day, did the other half. This is a picture I just threw in here of my dog. She's judging you. She's judging you for not annotating your pictures. So the idea here is that it's really easy to insert images into OneNote. You just drag and drop them on a desktop. The other thing you can do that relates to the next section is tables. So OneNote works really well with Microsoft Excel. I'm not sure about the Google free version. Whereas if you make a table in Excel, so you should really be taking all your data in Excel or Excel-like program. If you copy it, you don't have to retype it in OneNote. You just highlight the table, Control-C, and then Control-V inside of OneNote, and bop, it'll pop it right in here with all the formatting. It looks beautiful. So you're going to have to put all that here. This is for a small amount of data. If you have a lot of data, then you want to do is you insert your text file. So you can actually just take files the same way you drag and drop a picture. You can just drag and drop a file and throw it in here. And so, so some of these things, like anything that uses digital readouts of like spectrometer or equipment, you would upload the file here. Read the work there. Then you have the analysis section at the end. This is where you're going to analyze your data. So you'll analyze your data. You can see here's a plot. This is a plot I put in here. And then this is Python code to generate that plot. So any data analysis, you actually need to upload your code. This is kind of like the official sign off on that, yes, this is my work. You're uploading your Python file as code. That way I can always check it, and I can look at it and see your work and that kind of thing. So that's required. You do have to upload your Python code. First initial one, I'll be a little like nice about it, but eventually I'll start taking off points if you don't do that, if you don't upload your raw data, if you don't have pictures, like, like everything in this class, it'll start like I'll be a little generous, and then after I've told you a few times, then I'll start taking off points on that. Okay. Like I mentioned, in the middle of each lab, you're required to meet with me for a check-in. You have to have all your data and begun the analysis. If you haven't started any of the analysis, I'm going to take deductions about this, because last year I was a little nice about it, and what I found is that the students would come and they wouldn't have any analysis done, and it makes it really hard to talk about what you're going to do next, or even if you see if you did the experiment right. So make sure you do that. I'll send more emails when that happens. We've talked a little bit about the writing. I'll send more stuff out when we get to that aspect of the course. You're not going to have to write anything for over a month, so don't worry about that right now. 6 weeks. Plagiarism, don't plagiarize. There are very similar reports out in the wild, so don't use them. I'm a big AI known hater, so you can't use this. If other people have let you use it in other classes for writing, that's their prerogative. I do not allow it. Basically, all AI machines are just plagiarizing from previous work that someone else put in. So that's not really the point of college or learning. Everything needs to be on your own. Again, I do not consider any AI use acceptable. Since this is an asynchronous class, has a lot of writing, it's very independent, so I'm expecting you to do the work. Yeah. I have a notebook like I was just talking about before. I just showed it to you. Make sure you follow along with the outline I gave you there. And then at the end of the semester, we'll do presentations. I will talk more about that later. Basically, for your final experiment, instead of writing up a lab report, you'll do the same thing but for a presentation. I find that most students prefer that anyway, and it lets you see work from other students as well, because we'll present them in small groups. Okay, I think that's it for the syllabus quiz right now. So make sure you read through the syllabus, take the quiz, and then you also have 2 other assignments this week. I'll probably send out a separate email about those. But it's the uncertainties. This assignment here is the one where you'll watch a video about how to deal with significant figures, error propagation, and standard deviation. I've broken them up into 2 smaller videos. And then this is the assignment here, and you'll upload it on this page. Next week, I will send out more emails, but you'll have another 2 more assignments next week. Okay, feel free to email me with any questions, and I look forward to meeting all of you guys in a couple of weeks.